Okay, my friends, this is just too much. I've been taking this course at UC Berkeley, University of Tokyo. They're all hooked together. And it's called The Big Bang to Dark Energy. And it's revolution of the Earth, understanding ellipses in gravity, beginning of the universe, look far into the past, cosmic expansion, all of these things. So, of course, I go there to sort of be to ask questions. And the first question I asked is, how can you say that the space telescope is taking pictures of the expansion of the universe? Because it's the first thing they start into is the universe is expanding. We all know this because of the redshift. I said, well, the redshift is simply light slowing down. There is no vacuum in space. We know it's completely saturated with dust. How could you say the vacuum is there? And all they said was, that's a good question. Done. It's all over. There's nothing they can say about it because it's packed with particles of things. They're impacting as they're coming to it, slowing down. They say there's a vacuum in space. They know that's not true. It's impossible to believe a word these people say anymore. Now, this is crazy because this is UC Berkeley. I get up this morning, every morning I get up, and there's some crazy thing that comes up like this. Cracking the Oumuamua code, alien spaceship or natural phenomena. This is a comet, meteorite, meteor, asteroid, whatever you want to call it. It's floating through space. They have no clue what it is. I know exactly what it is, and I'll show you precisely what it is. All right, let's just cut right to the chase. This is a fingertip from a human hand, and the way the blood works is one of them is the artery that pumps the blood down and brings all that red blood through your whole body, and this is what they call the terminus, the terminal. And at this very end, it transfers over the blood into the vein and brings it all back up. So you have a red and you have a black. The black has clamps, a clamp, a clamp, a clamp, a clamp, a clamp, so the blood cannot go backwards. Once it heads towards the heart, that's it, case closed. It's used, it can't go back. The artery has no restrictions. It goes this way, that way. These here hook together and they all mix together. The arteries, but the veins, whew, straight back to the heart. No mixing whatsoever. These are both veins. You see these two, they come together right here. These are both arteries. All right? They come down and flush them down, with one or the other. But anyway, here's my point. This is saturated, literally saturated with blood. This is where I get the blood from to do my DNA test. This is where I had my DNA test done. Well, two of them were fingertips, and one was a lung. But a lung has just as much blood as a fingertip. They're both about the same. Now, here's how it works. Like I say, the red blood comes down, and then there's like two spots on the side and the tip. And then there's two spots on this side and the tip. These are the black ones that seal off. These are the red ones that blow right out. This is a fingertip. That's a fingertip right there. And you see this side right here is blown out? That's blood. That is blood. It runs right out because the arteries have no restrictions. They just run out. And that's the tip artery. It's right up here. Now the vein doesn't. You see the vein? It's clamped off. This is the vein side. All right, that's a fingertip. And I looked at this very carefully. Trust me, this is a fingertip. No question whatsoever about it. And these are where the blood leaks out because it's red blood. And I'll show this in a microscope. There's no question whatsoever. This is all covered with the fascia, which is feldspar, which is the skin. This would have had a fingernail coming down to about here. You might even be able to see some of it. Now, this little hook right here, you see that? This bump right here, this is all indicative of fingertips. These veins clamp right off, each one of those. Again, we're going to see it in the microscope. I'll show you this more carefully. The red blood just drains out. And that one just sealed off and turned into a red, almost like a garnet. All right, so this is a terrestrial fingertip. In the flood, flat, as they almost all are, squished on like that. Now, what if one came through space? And it was wet when it was in space. There was still wet blood in it. Well, guess what? This is it right here. That came through space as a meteorite. That's why it's all cooked up looking. And you see this side? That's the same as this side. The blood boiled and it exploded out of here. This just ran out because it's a terrestrial one. This cooked and exploded right off of the side. Boom! You see it all blackened up and heated up that blood, and the blood literally blew the side of the fingertip off. Now, you see this side here? Look at this. That is the same hook. You see that hook and this hook right there? That's the same hook. If you can see, you probably can't see, but right there is the vein, and right up here is the vein, which is the same thing here. Vein, vein. Now, you see the tip up here? It's identical, no difference whatsoever. And then this side is where the blood came out. This side it just ran out, this side it blew out. And this is the shape of a fingertip after you burn off all the fleshy stuff out. This is really the structural part of a fingertip, as this more or less is. This has been squished, all of the gooey stuff out of it, basically. And bones did not hold up well. That's why there's not some big bones sticking up here. The bones were disassociated from the body parts. Sometimes they turned flat. Sometimes they stayed round, like they were a regular bone. This one turned flat. Right? Because it must have had some pressure on it or something. This one didn't go flat like that. It just burnt off all the flesh. There was flesh around all of this thing. The whole thing had flesh around it. Now we're going to look at this again in the microscope. We're going to look at the blood. We're going to look at the tendon. See that? That's a tendon anchor. That's an anchor right there. They came in and they anchor right into the side of the fingertips. And I can show you where they anchor. This is where they anchor right here. This is a DNA tested, CAT scanned, anatomically exact fingertip from, and I have the hand and I have knuckles and all kinds of things. But that's how they lock in here. All right, that's the fingertip. Now this is an area where the apical tuft is right here. And you see these little strappy looking things? You might be able to see them in the shadows. They run all kinds of tendons down to make your finger be able to do that. I have a tendon enthesis here somewhere. Here. These sit right at the end of your fingertip. This is what the apical tuft is. And all those balls, there's one still left in there. It was right up there at the end of the fingertip. All these balls are those straps that run back. This would have one too. It's got one in there, but you can't see it. This one has one. You can actually see the outline of it because it's on the top too. You see that circle? That's basically this circle here. Right? I don't know if you can see that or not, but it is. And then on the other side, same thing. This is it right here. That's it. All right, so because I have so much of this stuff, it's absolutely stunning the amount of these things I have, and bones and blood coming out of them, actually scabs and blood coming out of these stones. And this came through space while it was still wet. That's the only possibility I can think of. And it vaporized the blood that was in here and exploded it right out of there, blew that right off, instead of just hardening up like this. It boiled all of the pockets out of the tendon straps. These are straps. You see that strap coming down here? It comes right down to this tendon. There's the neck to the tendon. That ball is the tendon ball. There's the neck to the coming up here, and that's the strap. And these straps make your fingers be able to do all these special little things. That's a meteorite. Anybody want to confront me about it? I'd be glad to discuss it. I have iron ones too, that still have blood in them. Actually, really, literally raw blood. And I'll show you iron ones that they slice right down the middle, and there's a vein and artery right in the middle of them. This is not something, there's no hidden stuff here. It's just got to be looked at. Okay, so you know I'm going to UC Berkeley, Tokyo, University of Tokyo for space. Basically, the expansion of space, all this stuff that they're, the theories behind it. And immediately they started out with, we all know that space is expanding. Well, no, we don't know that. Light is slowing down. And that's the first question I asked, I think I mentioned that, was if there's so much dust in space, why do you think the light isn't slowing down? It's not a vacuum. And then they shut it off right from there because there's no way to respond to that, because it's true. There's no way for light to just never slow down. It's coming through a soup of particles. And even Fermilab 10 years ago wrote this. Empty space isn't empty. This is Fermilab from 2013. Fermilab, they know this. They say it's a empty space experiences similar activity as a bubbling root beer. But it's subatomic particles winking in and out of existence because they're getting banged and not banged, and banged and not banged, winked on, wink off, wink on, wink off, wink on, wink off, wink on. What do you think? It's not going to slow down the stuff that's coming through it? Obviously it is. They know that the universe is completely saturated with particles now. There is no possibility that the universe is a vacuum and that light does not slow down. It obviously slows down. It starts out coming fast like this. It spins, light spins. That's what happens. It's not going like this, and everything's pulling away from it, so the light is getting stretched as it goes. That's what they claim, which is the most ridiculous thing I've ever heard. And they won't respond to the fact that space is filled with particles. So respond to me why Hubble should be able to detect distances, because light goes so far in a year, and another year, and another year. No, it might go through that one and nothing there. Yes, maybe, and it just goes the speed of light. But the next year it might go through a whole batch of dust, and just like you hit a bunch of water. So this is just absolute nonsense that the universe is expanding, and we know that for a fact. That's absolutely, completely nonsense. And I pointed that out, and you know what they responded with? A whole batch of different calculations showing me all this pi 2r squared d, lot. You know, we know this happening because of the shift of this and the frequency and the resonance and the diatomic polar bisexual, who knows what they got in there. It's unbelievable. And these are the people that are absorbing. Fermilab, I think their budget is like $27 billion. Have no clue what they're doing whatsoever. None. Oh gosh. All right, so once again, here we go. UC Berkeley, they're trying to figure this out. 2017, the comet's unusual acceleration explained by hydrogen outgassing from ice. That's not too far from wrong, but I'll explain to you really what's happening is the sunlight is pushing it. They're saying that the fact that it was accelerating away from the sun in a way that astronomers could not explain perplexed scientists, leading some to suggest that it was an alien spaceship. No, it's being pushed away because light pushes things. You want to see light push something? I'll show you. You want to see something nobody's ever seen before? Light pushes light. And what do you mean by that? Light pushes light. Well, there's dark light and there's white light. This is your dark matter. It's attached to the white matter, which is light. This is the two of them together make light. Light is this right here. And all that is two of these back to back. These two together make what we always thought would be an electron. All right, the electron is like this. That's what an electron is, just like that. One side's black and never gives off anything. It's a dark matter. It's heavy and it pushes the glowy part. And can I prove that? Yes, I absolutely can. And here's what they come through the air. The one that's going forward is pushing other particles in front of it. It gets glowy. The one in the back gets dim. Can I prove that? Yes, I can. There it is right there. These are the particles from Fermilab and CERN. They have found them, but they just find them in a pile of debris. We watch them as they accelerate, and they turn into these particles. You never see these until they start accelerating going through our Venturi. And that's the Venturi right there. Accelerating the light. Virtually no question about it. And there's no question that the black leaves the white, and the white makes an electron shower, and the black turns into a sterile muon. Precisely, exactly, identically to what CERN and Fermilab would like to do, is to turn this electron neutrino, which was the white ball, and the black ball together, called a dirac, turn it into a sterile muon and an electron shower. Precisely what we did, breaking those apart, because only the white can get through the Venturi the way it was tuned here. We have another one that was tuned so both of them can get through, and you can see the black pushes the white. They're both, see, this time a little bit of black came through. The other time, zero black, not a tiniest bit of black. So we see the black is pushing the white. What happened before? Why was this all white over here? It's because the black was slapping the white through. This time, the black is pushing the white through. Before it was a slap. This time it's a push. This is a slap. All right? And the white goes, but black can't get through. The black just goes hanging off to the side here. And it goes around. The white is getting slapped. Just like that. And I say that that slap could push that white juice, that white eau juice right there, down through a photodiode, which means it accepts the photons, goes through them. Can't come back. It's a gate. It goes through one side, cannot come back. That's how we could use this to make free energy. That is an enormous increase in energy from what it was back here. We did nothing whatsoever other than put it through the Venturi to create this reaction. This should give us free energy. All right, so I am against the current indoctrinated science and forced sciences that are out there right now. They will not look at this. I've been trying to engage for 7 years with Fermilab, and I've talked to Don Lincoln, and I talked to a bunch of them, and they all refuse to engage because I'm taking away their bread and butter, basically. We did exactly what they wanted to do. They cannot do it with protons. You can't do it with protons. They're much too big, gigantic. They're 1,823 times bigger than an electron. But they are made of those electron particles, which are these electron particles right here. One is an electron, the other one's an electron. When they're together, they're a photon. But when they're apart, they're an electron. And then these two can come apart and become a sterile muon and electron showers. So these are the tiniest bits that exist. And Fermilab and CERN also agree with this. This is not just me. That's their picture right there. And as a matter of fact, they do precisely what I'm saying they do. Here's Don Lincoln's article about it. What's the point? He shows the particles we show. Here's the particles right there. That's the ones I just showed you. And this one is a fixed particle, can't get through the slot. This one's a gooey one, it goes right through. See, it's exactly what he says. Right here, in summary, the extended particle, the black one, has a fixed size. It can't get small enough to get through the slit. The other one has but it does also have a fuzzy edge. That's the color. And you saw that fuzzy edge. Let's just be sure you understand. Here's the fuzzy edge. Whoops, here's the fuzzy edge around the black ones. You see? It's fixed size, never going to get smaller than that, never going to get bigger than that. And it just pushes the white ones. It's a carrier. They call it a carrier boson. I'm not making any of this stuff up. If you think you can go against what I'm saying, come on down, let's talk. So the extended particle is a black one. It's fixed. It never changes. It has a fuzzy edge. That's the color that surrounds it. You can see it's in there. The point-like particles are mathematical abstractions, zero size. They have no size at all, so they go zip. But because even the zero-size particles have extended fields around them, which is their magnetic field due to the effect of the field surrounding them. Now, I can't see something having a field surrounding something that's nothing. So something must be there. There's got to be some kernel of something, I would think. But from the atomic bomb blasts, I see that it's virtually exactly what he's saying. And the two particles go together, and they make mass. But the key is, we've never seen what's inside of the mass, because by the time they hit protons, the dark particle is, all of this dark stuff congeals inside, just like a black ball inside the white. All the white surrounds it. And it's the black is sucking it right in. It's gravity and it's dark matter. All right, see this, all the fact that it's accelerating away from the sun, it's being pushed away from the sun. There's no mystery here. It's not an alien spaceship. It's a fingertip. It's a complete finger, and I'm going to show it to you right now. I'll show you the anatomical. I'll show you the pictures they took of it. Now, everybody say, "Oh, that's just a rendition." No, it's not. It is photographs over and over and over from every different angle, and I do this all the time with my microscope. I have to change the angle to see the different shadows, basically. And once you make a picture that way, or you can see it just changing it so the shadows change as you go, you can see literally every detail. And that is what they did, and it's a fabulous rendition. All right, this is going to be hard for you to see, but this is a picture of a Maro. And the knuckle is, I'm going to go actually draw it on the screen and show you what these tendons are, where the grip skin is, where the vein and artery attach, all that stuff. Where the angles hook together here, where your fingers meet, and you have this spot. And I'll show you actually on some bones. I'm going to show you. It's a fingertip, and the picture of it that they show is not just some drawing somebody sketched out. It is overlay as it spins through space, seeing the different shadows overlay each other and make absolutely flawless. And I showed this to one of the top anatomists. I believe as far as I'm concerned, he's as good as anybody in the world. And he's also an autopsy anatomist. And he looked at this and he said, "It's the fingeriest finger I have ever seen." Now, I don't think he wants to be identified as agreeing, but because people seem to think that anybody that agrees with me has to be out of their mind. Anyway, I'm going to show you what it is. And it is what I'm saying it is. And if you can get a biologist, an anatomist, a doctor, somebody that works with hands, to discuss this with me, I'm showing the actual factual evidence. I don't just go for guesses and, it must be an alien spacecraft, or it's, outgassing this or that. Well, I can see what it's doing. I can see what all of these things are doing, and I know what they're doing. I know the chemistry, I know the anatomy, and after studying the ancient texts, I know the history. And the people that are running all these things know none of that. Zero. It appears they know none of that stuff. They think space is a vacuum. Absolutely not a vacuum. No question whatsoever. But they keep saying it's a vacuum. And they keep saying Hubble works. It doesn't work. Take some nice pictures, but that's about it. All right, I'm going to tell you right now, when this is coming through space towards Earth and cooking, it's literally just like it's on a barbecue grill, and all of this stuff is smoke goes into space. Now, the astronauts say that space smells like steak, burning hot metal, seared steak. Exactly what I've been talking about is these transition metals. These transition metals are what is in your blood. If you don't have those in your blood, these transition metals right here, you will die. Especially iron. You can die in a couple of minutes without iron, because iron carries all the oxygen around. Now, all of these other metals carry other things through your body, little building components here and there, and they drop them off with these oxygenation states. That's what's called nucleophilic substitution. They come in as an invading group, they drop their stuff and invade, and they pick up other stuff and leave with it. That's basically how it works. In aqueous, which means wet, salty solutions. That's what they're smelling in space. Where would those come from? Well, they're trying to figure it out. Boy, they can't figure it out. I can show you exactly where they come from. Very simple. All right, here's where they came from. These are literally body parts in space. That is a tendon enthesis. I'm going to show you very closely. These are all the coma. This is just not dust. That is literally cooking from these huge voids which were where blood was. Oumuamua is a finger. We're going to look at this extremely closely. This is Comet 67P. And I will, again, look at this. There's no missing this. You can't miss this if you're, and I show these to anatomists, they say, yeah, you're right. That's a bundle of muscle right there. And these are the tendons. This is the abrupt transition where it breaks off as it starts to go into the muscle. This is the tendon enthesis. All of these little pockets are little grabbers that keep this stuck into the body that it was in at one time. All of this is eroded red flesh that eroded out of here. That's a bundle of muscle. These little pinchy bundles, you see them? These little pinchy bundles with the core in the center. That's what the muscles come up, and they're straps, literally straps. Now, when that thing comes through the atmosphere, or actually through space, because Comet 67P didn't hit the Earth. If it did, it would be a very bad day, especially if it hit Raleigh, North Carolina. This is very, very large. Now, this is Raleigh, North Carolina. Like I say, it wouldn't be a good day there. Now, why is all that dust coming off of here? Is this dust? No, it's not dust. It's not just blowing off and drifting off into the breeze. It's shooting out of every single blood vessel. Because blood has these transition metals that are boiling off. They're cooking just like they do on a gas grill. And the sun is hitting this one here. Why is that? Look at that sucker. Whoo-hoo-hoo. Look at that thing go. Why are these just little bitty ones that's so gigantic? Well, I can tell you obviously why. These are blood vessels. They support the tissues right in this general area. Same thing with these. All these, they're shooting all in the direction of the blood flow. This one's shooting sideways, up, up, up. These are shooting all over. This is an artery, and that sucker is huge. These little grabbers here were what implanted that into whatever it was in, a bone or whatever. And this is Comet 67P. I followed this closely. I have it right here. Here's the spectral analysis of all of the different chemistry up there. It's almost all hydrocarbons, ferrous oxides, which is iron in your blood, sodium, silicon, everything. It's exactly identical. And they agree with it. Nobody's contesting this whatsoever. They just don't know how to respond. This was where, remember that gigantic one coming out of there? This is it right here. Look at this. 40 meters is that wide. So I'm going 40, 80, 120 minimum meters of an artery. 120 meters. All right. That's like 360 feet, something like that. I don't know what it is. But it's 300 and something feet across. One single artery. These are what they call the dragon balls. You see these little balls here all over the place? These are little balls of blood. That's where the blood vessels enter in to service the tissues. And then all of those little spots coming out were just small little ones. As you recall, I believe this shows them together. That's the monster. That's the artery. That thing 300 and something feet across. These are, I don't know, however big they are, but they're good enough to where when the sun hits them, they cook off. Now, you see this? There's no cooking here. There's no cooking here. Why? I can tell you why. These are anchors. Going up, there's straps attached to the balls. These little pockets, and I'll show you the anatomical. This is a tendinenthesis. This went up to a muscle. Okay, I have shown you the blood gushing out here, well, the vapor from the blood from the huge artery that ran down there, and all the little spots. And as I told you, this part here, there's no vapor coming off of this. And the reason is, these are not biological, as you think of biology. They don't have a lot of blood in them. These are like hard pockets and balls. And I will show you those anatomically. They don't strap up like the other ones do. You see this here? These are the anchor balls like I'm showing you on that other one. Then here they go up and they have all these fibers. These have to be fed with different metals and so forth. They do a little bit of a different job, and there's a lot more chemistry around here. These are just pockets and balls that sort of lock it in place so that it's got something to, pocket. It can't be smooth to pull right out of there. That's what a tendon does. It creates a entanglement. Think of it that way. And that is what is happening here with these particles here. These don't smoke. The rest of them smoke off wherever they fed up the blood, which is literally this was the blood. It's eroded now into dust. But none of this just blows off of these things. This is all shot out. Comas are not like they think they're just a bunch of stuff blowing off. No, absolutely not. And the reason Omaro is going away from the sun is the light of the sun is hitting it and pushing it away. It's not a big stretch here to understand this. And like I showed you, the light has a dark and a white side. It pushes things away. The black pushes. All right. What else can I show you here? Oh, I was talking about blood in the meteorites. I showed you mine. There's a ton of blood in here, absolutely saturated with blood. Now, I think it's denaturized, denatured, because, in other words, it's destroyed because of the heating up. You can only heat the blood and biology up to a certain point, and then it breaks the bonds, and then it just no longer does biology, Anyway, this is a meteorite. That's an iron meteorite. Came through space, iron. Well, what is this blood doing in the middle of iron? There's a blood spot right there. You see that? See how red that is? What's that doing in there? What is that doing in amongst all those transition metals? Because this was a heart or a lung, something like that, maybe even a kidney. I'm sorry, a liver. But it's basically saturated with blood. And all of the cheap stuff burns off, all of the skeletal stuff, all of the fabric. I call that the cheap stuff. It's once you get into the metals, you're up higher up into the periodic table. They don't burn off quickly. They turn into this ball of festering metal, but still has its blood inside of it. That's blood. All right, and all those other different mineralized looking things, the different colors, and those are just these different transition metals. Every one of them has a different molecular signature. And blood is just quite so obvious, it's unbelievable. This is the outside edge. There's blood outside here too. But everything here, this really burnt off. When you have a big, heavy object coming through space, and there's two ways of it coming through. It can come through with the rotation of the Earth, which buffers the impact, and it can come through against the rotation of the Earth. And then you really got some cooking. That's the two different ways they can, well, it comes sideways or whatever. But head on is a cooker. And going with it sort of lets it fluff down, and they actually have meat, literally meat, coming out of space. In Kentucky, I think it was 1876, let me look it up. It's right there, Kentucky meat shower. All these chunks of meat coming out of space. landed in this woman's yard. Apparently they still have some. One guy ate it. He said it tasted like elk. Want to see something cool? Watch this. I showed you my fingertips, and one of them was a terrestrial, one of them came through space. This is a terrestrial lung. All right, it had all eroded out, but it's absolutely a lung. And these are the big cavities. There's one big one where the main part comes in, and then it goes out into all these alveoli around there. So what is this? Well, that is also a lung, only lungs are loaded with blood. This came through space. That came through space. And that is an iron meteorite. It's one of the biggest ones there is, and it was removed from a sacred Indian site, and now it belongs to, I don't know, some museum, apparently. You see that spot right there, that red spot? That's an artery. That's an artery right there. And there's a bunch of them here. You could get some blood out of that thing. You could actually test that. You see it right there? Now you can see a spot. That's the, you see it. That's an artery. And they all have them. I mean, obviously, you have to have that blood passing through. And this is all iron now. And that's why you have all these cavities, the same as the cavities on mine, only mine just leaked out. This burnt up until all it had left was mostly the metals. I'm showing some pretty good evidence to support my side of this thing. See this? This is a meteorite they're showing from NASA. It's nothing more than exactly what I'm showing here, my bone, this bone head. You see the two dots right there? That's those two dots right there. And if you can see the other side of it, it's a bone head. It's exactly like this, identical. Only it came through space and cooked off all the fascia, turned into just like the skin on a chicken would. All right, let me show you something. This was a hand. It's I don't know, 3 or 4 feet wide, something like that. And this, and I had this, it's on my property. I discovered this 12 years ago. And I had a DNA tested. Well, I had parts of it DNA tested. It has fingers and knuckles and all this. This was when I first took it out of the ground. Now, you see this silvery spot here? All this silver stuff, and it's how it's peeled back. You see it? This is what's called grip skin. This is on your fingers, your toes, and it's a very keratinized, heavy-duty skin. Now, I also had another big, gigantic fingertip, which was 3 feet long, just the fingertip. I think this was either 3 or 4 feet wide. Again, I think it was 4 feet wide. This is a bed sheet. Anyway, this is the pad around it. This is the little cleave between your pads. This is a left hand, and you could tell this because of the tendon. The tendon runs down this way, off to this side. The cleave is here. This pad runs right off to where the little finger would have come, right up here. This is the key that tells you. Somebody else, oh, no, that's not a left hand, it's a right hand. Well, that's what I originally thought too, but it's not. It's a left hand. This is only right up here to about here. This is not all the way up here. The knuckles and everything ran up in this area here. By the time you got to here, you had to go way up over here. And I have these parts. I have them in my shop here. And I had it anyway. But the point I'm getting at is this silvery skin. I'm going to show you that on a Maro, because a Maro is a fingertip, and some of its skin has eroded away. Let me show you what grip skin looks like in an anatomical. This is from my giant fingertip. It's 3 feet long, just the fingertip, and the fingerprints are still on it. This is the sweat pores. You see it? This is grip skin. It peels off just like that. And underneath you get that, what I just showed you, the palm, is underneath. It's a nice red color. This was that silvery stuff, and it comes right off because it's got a different chemical makeup to it. It's much more really tough as hell. And it wrinkles and rips right off. And this is the fingernail was still on there too. Hold on, here's the fingernail. That's the fingernail right here. You see it? And I broke that off of here. That was solid. It was all one piece. But you can't get blood out of that keratinized stuff. So I smashed it with a big heavy duty hammer and that just popped right off. I was kind of surprised. I didn't realize it would come off in a layer like that, but it did. It came off exactly like you saw in that picture. This is just a layer, just exactly like this. It popped right off. So, this was DNA tested, and it's human, and so was the hand, the big hand that I showed you, and a lung I also had DNA tested. That's right over here. All right, I've shown these so many times now. People are getting upset I'm showing them too much. Well, when it becomes common knowledge, I'll stop. How's that? This is the flat spot on, virtually all of them have a flat spot because they were all in the flood. And they pretty much know this now. I mean, there's no argument about the flood. Yale says, yeah, there was a worldwide heavy inundation of salty waters that preserved all of these soft-bodied creatures, exactly like I said. And that was only 3,500 years ago. All this stuff was on the surface of the earth. I didn't dig for any of this stuff. It was just laying there. I mean, some stuff maybe got dug up when they built my house and so forth, but I didn't go digging anywhere. It's just laying there, just everywhere. And I mean, it is everywhere. This appears to be a real hot spot for preservation, because everything I have is almost, well, look at this. Look at this. Nobody's ever seen one of these before. That's a no-toe. It has toes built into it. That's a foot. And it has the same thing we have. It has a tibia, and then it had the fibula that sit right there. There's 3 different attachment spots to hold it in, but when the thing goes into mudfossil mode, they just fall off. And all of our no-toes, and we got a lot of these, they all fall off just exactly like that. And the toes are built right into them. They have the same arch and everything like ours, but they have springs inside, and so these are springs. That they don't have bones like we have. And I've shown this hundreds of times, hundreds. So I don't know how much more I can do of this until people start paying attention. This is our real history. So a lot of things have to be thrown out. That's the problem. They can't come to grips with this. They're very upset, the academics. They totally hate me. I mean, as much hate as you can have, they got. But anyway, let's get back to Amaro. All right, this is going to be a anatomical experience here. This is a fingertip, and I'm going to draw it out for you. Now, you see these little spots right here? Oh, pay attention to this. All these little dots here, and that little cleave right in there. That's this right here. That is this right here. Every one of these has tendons that lock into all of these little balls here. And then you have your crease, and then the other one has the same thing, and you can go back and forth like that. Now, this goes all the way down, and it has all these tendons. At the bottom, you have your vein, the black one, and you have your artery. All right, and these are your tendons right down here that run across. They come right up over the top. This is that grip skin. Remember I just showed you that grip skin? You see that? That's the grip skin. So right here is where the fingertip skin is peeled off. This right here, remember I showed you the apical tuft? The apical tuft is this right here. And it has all those little balls in there. And all those little balls run down the straps that run down your finger. And I don't know if you saw it in the anatomical, but I did show it to you. Now, here's what happens with the tendons. First of all, that's the apical tuft. And all these things are running down, coming out of that apical tuft. It has all these balls in there. And all of these straps run down your finger. Now, here's the main one. Here's the main strap. Let me get this out of the way. Here's the main strap. It runs right here. You see it? Right to there. That's what does the main work in that fingertip. Then you have this crease. Then this one runs down, all the way down. You see him running down? Runs all the way down like that. And here's where it attaches. Here's where it attaches. Now, so let's get rid of that stuff. So here we got a finger that's doing this. Well, here we come to this. Is up over the top. This is the bottom part of the finger. It comes up over the top. This is where it rides over here. All right. This is the artery, vein, black. This right here would be the artery. These two are the main tendons that run down, and there's two really heavy-duty main ones that run down, and that's them. Whoops, I realize you can't see that. Let me just finish this off by making sure you understand. This is the vein, black. This is the artery. These two are the main tendons that run down to make your finger be able to really, those are those really big dogs that run down there. Now, as you can see, I hope you can see it, as I showed you before, this is the main tendon. It breaks right here at the knuckle. The tip is up here, and the apical tuft is there. This grip skin is here. The knuckle's there, runs down to the bottom here, all the way down to here, which is right there. Running over the top, you have the two main tendons, and here's the blood supply here and here. That's umaro, and the reason it's such perfectly, the picture is so perfect, they take this from every single different angle as it's going through space, and then they make a composite based on shadows. And it's, like I say, I had really a very, very top autopsy anatomist look at it, and he said, absolutely no question, that was a finger at one time. And if anybody can dispute that, I'd like to have them dispute it. Harvard, Avi Loeb should have some anatomist or somebody up there that knows biology and knows anatomy. But they don't. Nobody communicates between these different branches of science. They're all, oh, I know everything about asteroids. Well, what about this? I know everything about comets. Well, what about this? I know everything about geology. Yeah, well, what about that? This is all new, and they are just furious that their authority has been, diminished. Let's put it that way. It would not have been had they embraced this and said, this is something we missed. Let's take a look at it. No, never happened. And it's still not happened to this very day. They're just making up, they're concocting stories to use the students as a source of income. Okay, speaking about students being used, we are starting a true, real, fully functioning Mudfossil University school. We're going to have our own library, which replaces all the books now because they're not right. History is completely wrong. Geology is completely wrong. A lot of the chemistry is wrong. Light has got to be reassessed completely. The electron flood theory replaces the standard model very elegantly. There's very, very, very little that's correct in mainstream media right now. It's just not right. And they cling to these standard values that were wrong, because if they go against them, they will be destroyed. That's just the bottom line. Velikovsky had it happen to him. It happened to me, but I can't be destroyed because I had nothing to destroy. These other guys had careers. They had jobs. They had all those things. They had friends and all that. They lost everything if they start talking. I thought that was gone. So to me, I didn't really care anymore. So we're going to have our own university that allows you intellectual freedom. All right, that's a big, big discussion now. Well, you can't talk about this because it goes against this, or it goes against God, or it goes against civil rights, or it goes against gay people, or it goes against this one or that one. You have to have open discussion. And then you have to have compassion. Everybody is an individual. Now, you don't live in their body. They don't live in your body. Will they find God? Is there a God for them? I don't know. Is there a God for me? Well, I have my own beliefs on this now. So a lot of things have changed for me, a lot of things. And I do believe that there is some major God creature that is running either the entire show or at least this section of the universe. I mean, the only thing I really have locked down for myself at this point is the fact that Jesus Christ was as advertised. I believe that now. I never did before. I thought it was just nonsense. But now, after doing a lot of research, I believe he came back, he said, you're going to be disturbed, you're going to be upset, you're going to be marveling at the things you discover once you seek. And don't stop seeking until you find. And that's exactly what I did. And I found, and I was disturbed, and I am marveling, and it's nothing like we were told. So who do you believe now? Do you say, oh, no. Like I was just talking to a guy the other day. He says, I was scared to death to read anything other than the Bible. Any of these other things, they were just there to destroy my life. Well, I can't say that's not true. I don't know. But I look at everything and then I make my own decisions. And I believe that's exactly what Jesus Christ was saying. He says, seek, seek, seek. And don't stop seeking until you find, and you'll find, when you do find, the earth is a corpse and a body. That's exactly what he said. And he also said you will marvel and you will be extremely disturbed. And that is a fact as well. Because everything I was ever dictated to by schools and so forth was just, it wasn't wrong. And I stood up to it, and they smack you down. You can't fight authority. Authority always wins. That's just the case. Pretty good song, too.